Question 4 in the revision exercises has 10 parts, so one of these long junior cert questions they really want you to concentrate on. So read it carefully. Mary is planning to hire a car for the holidays. She has the choice of two companies, Don't Walk and Drive. Charges 20 registration fee. So we can see down here there's a table we're going to fill out. So 20 registration fee. And Go Drive has no registration fee, but it charges 25 a day. This one's 20 a day, so they're going to catch up with each other. Sorry, 15 a day, 20 is registration. So day one, it's going to be a total of 35 with the extra 15 a day, then 50, then 65. You're just adding 15 on each time, then 80, and then 95. And for Go Drive, 25 a day will just be 25, 50, 75, 100, and 1, 2, 5. We can see here there's a point of intersection where they're equal. So we've completed the table. They want us to graph the information on an X and Y axis. So you will have rulers that are to scale. We have 3, 4, 5, just 5 days on the X axis. We can label that. Say days. Then on the y-axis going up this way, we have to go up to 125. So we might go up in 25s, 25, 50, or maybe we go up in 20s, 20, 40, 60, 80, 100, tiny bit more, 125, 20, 40, 60, 80, 100, and 120. And along the y-axis, we have the cost. And let's put the information down. So the intercept for Don't Walk, Drive is at 0, 20. And the end point will be 595. So we go to the end point, 595. And if we connect those two, the rest of the points should fall in place. And then for the second one, 0, 0 is the initial at 0.0, and then we have 5, 1, 2, 5, 5, 1, 2, 5, which is above here. And then if we get the point of intersection, we should be able to match them all off. 250 is the point of intersection, which is approximately here. So stick your ruler down, make the point of intersection work on your graph, and we have it graphed. So the slope or rate of change from the graph using your table or graph, where we know that slope and rate of change is the change in y over the change in x, and x is changing by 1 each time. So here we have the change in y is 25 each time. So slope of 25. And we take that onto the graph. 250, we have a 2 and a 50. Rise over run is equal to 50 over 2, which is equal to 25. And then the slope of the other graph, we have 2 again, but we have 30. So 30 over 2, the slope of the blue would be 15, which you can see is the increase in price on a daily basis. And a formula that relates the cost of the car rental to the number of days. So let's write down our pattern, starting at day 1. So 35, 50, 65. We don't need to write them all, but we've got a 15n, the increase in cost per day, plus 20 to get to 35. And then for Go Drive, we have 25, 50, so it's just 25n, 25, 50, 75. So 25n is Tn. And then the rest of the questions. From the diagram, the point of intersection we saw was 250. Explain what it means. Well, cost the same. So the questions are normally not that difficult when you're able to do the maths. So it can be found, the point of intersection, by using graph or algebra. One advantage of finding it using the algebra, we get the exact answer. With my graph, I had to make it a little bit bigger to fit. And using algebraic methods, we have to let the two tn's equal each other when is 15n plus 20 equal to 25n. So 20 would be equal to 10n if we bring the 15n across, so n would be 2. And then we sub 2 back in here and we get 50, and we sub 2 back in here and we get 50. And then how much would each company charge for 15 days? 15 by 20, we'll do the first one in red. For 15 days, 15 by 15 plus 20 is 225 plus 20, which is 245 for this one. And then 25 by 15 is equal to 250, and 125, which is 375. So a long question, just do one little bit at a time. So in this question, it's the start of quadratics. So we're looking at 1, 5, 10, 16, and what we're going to do is we'll answer these questions, but we'll also find Tn in these questions. Once you start getting good at Tn for quadratics, they become really easy, and you hope it comes up every year. So the differences here are 4, 5, 6, and the second difference is 1. And the rule that we've learned in class is that 2a is equal to the second difference. So 2a is equal to 1, a is equal to a half. And every quadratic is an squared plus bn plus c. That's Tn. So to find c, we do next, we go, here's term 0, which is equal to c. Always. We saw it as the point of intersection on the y-axis in the last question. And we continue our pattern backwards. 6, 5, 4, and 3. 5 minus 4 is 1. 1 minus 3 is minus 2. So in this case, C is equal to minus 2. And we also know that A plus B plus C is equal to term 1. It's always term 1, which is 1. And we have A and C, which is going to add to minus 1.5. So minus 1.5, these two added together, A and C, plus B is equal to 1. So B in this case is 1 plus 1.5, 2.5. So Tn for the first question is an squared, a half n squared, plus bn plus 2.5 times n, plus c, which is minus 2. And if you always with these check maybe term 2 or term 3, so if we put 5 in for n, we'll do it up the top, we're going to get t5 will be a half. So put 2 in for n to get 5, term 2, a half times 2 squared plus 2.5 times 2 minus 2 is a half of 4 plus 5 minus 2, which is 2 plus 5 minus 2, which you can see is equal to 5. So we check Tn, it is 5, and you know you've gotten it correct. So let's look at the next two. 2, 8, 18, 32. So the second difference we want to find. The first difference is 6, 10, 14. Second difference is 4. So 2a is equal to 4, following the same pattern. A is equal to 2. Can we find term 0 in here? If we continue the pattern down, 10, 14, 10, 6, 4, not 4, down 4, 2. So 8 minus 6 is 2, 2 minus 2, term C is equal to 0 in this case. And then A plus B plus C is equal to term 1, which is 2, term 1. So A is 2, and C is 0, so 2 plus B is equal to 2. So in this case, B is equal to 0. So it looks like in this case we have 2n squared plus 0n plus 0, but we don't need these two. And then when you line the pattern up, you can see that the square numbers are 1, 4, 9, 16. So in fact, you can see that this is n squared. The one below it is twice the above one, so 2n squared. So we can see that we're correct on this one too. And then the last one, when we start having plus and minuses numbers, you might get a bit confused, but just follow the pattern. We're going down 4 to 6, we're going down 6 to 0, and down 8. And then we're going from -4 to -6 is down 2 and down 2. So we do have the same second difference. So -2 is equal to 2a. So a is equal to -1. Can we find term 0 here? -8 going in this direction, -6, -4, -2. So 6 minus -4 is plus 10, be careful. And 10 minus -2 is plus 12. So we're going to get C is equal to 12. And A plus B plus C is equal to term 1. In this case 10. A and C add up to 11. So 11 plus C is equal to 10. So C has to be -1. So Tn is equal to an squared, which is -1n squared, plus bn. Sorry, I wrote C here. That's b. So b is -1, so -n squared minus n, and then plus c, which is 12. And we'll check term 2. It's going to be -6 squared. Not 6, 2 squared, -2 plus 12. So that's going to be -4 minus 2 plus 12, which is equal to 6. And hopefully term 2 is 6. And you can see that you've done it correctly. So the question, we're only looking for the next 3 terms in the first and second differences, but you guys should be experts at TN if you're watching this video.